Okay, perfect. Hello, everybody. Just before lunch, so let's take it a quick one. This is my talk. It's about MoodBot. It's about raising tiny robots with Elixir, nerves, and AI. And a quick one about who I am. I'm Carsten. Did study computer science a while ago, did my PhD in math, and then transitioned to software consulting with TNG, which is a Munich-based consultancy. But this will become interesting later. But for now, the more interesting part for the talk is that I'm also the father of two boys, 7 and 9 years old. And my oldest son, a while ago, asked me the question, like, can we build a robot? Which is a pretty reasonable request for a boy, probably, and for kids especially. And but also he asked, like, can it move? Can it talk to me? Can it interact? So it's a little bit more complicated. And this talk is about my journey, what we did, actually. So the first spark was initially, I would say, like when he was 4 or something. He got this toy robot. It gets a remote. It can move. It can dance. It can make noises like standard robot toys you have. But apart from that, it couldn't do anything else. You couldn't tinker with it. You couldn't program it. And yeah, so he lost the interest quite quickly, I would say, which is completely understandable. Then, interesting, this doesn't play, but this is okay. Then let's play this way. 2 years later, we got this DIY robotic arm kit, which you have assembled yourself, and he helped me to assemble it. He tightened the screws and so on, and it has some servo motors, and you are programming this one with Python. So from robotic toy to actually doing Python programming is a really steep learning curve, I would say. So I did the programming. And 2 years later, we occasionally visit the German museum in Munich, and they had once a robotic exhibition, and one of the employees was walking around with this Unitree GO2 robot, like a small robot, not so small robotic dog, cost like a couple of €1,000. And all the kids were like, wow, this is cool. And of course, my son said, reasonable, we should build this one. So yeah, I couldn't do that. But we talked about early this year, again, like how we could build a robot. Could we do something ourselves? And he then suggested he could just draw something, because every cool robotics project needs a cute avatar, of course. And I thought, like, he will draw just one avatar or something, but he came up with a collection of mood faces for robots, so Minecraft inspired, I would say. And this is perfect, because we came up with the idea that let's build a MoodBot, something that interacts with you and mimics your emotions in some way. The question was, in what technology should we build this? From my professional experience, I came through 4 different language ecosystems: Ruby, Python, C, and TypeScript, so nothing Elixir, Erlang, whatever. So the nice things are not there. It's a part of Ruby. I like Ruby. And during my Ruby times, I also got introduced to Elixir, like a cousin community of Ruby, and it was really nice. I liked the language, and I took the language for a couple of internal workshops we gave at our employer at TNG, and also for side projects. But it's just in my spare time. So I could have just opted for Python and be good to go, but I wanted to use Elixir because it's nice. So what gave me the confidence push to actually start it, because on my daily tech, I don't use Elixir at all. It's just the part-time that I have, the spare time. 2 things that Josh also in his keynote this morning mentioned were introduction of the MCP servers end of last year. So I thought, perfect, I could just use MCPs to fetch hex docs, fetch GitHub documentation, whatever. And also then Ardai Kaparthi, when he coined the term vibe coding, I thought, like, okay, I've just so little time, I could just write the docs, spec-driven development, and let the AI figure out the rest and tell me about all the gaps in my knowledge that I actually have. And there are a lot when it comes to Elixir. So I just came up with a pretty fuzzy plan. The fuzzy plan was just pick up some hardware I have in my drawer, Raspberry Pi, like probably a lot of us, and attach some display, speakers, and microphone to it. So the display displays the mood phase, renders it. The speaker does some text-to-speech. And the microphone, yeah, you can naturally interact with it via speech. Pretty sensible. So I started picking the display. But before we can actually attach a display to the Raspberry Pi, we need to run something on the Raspberry Pi. And I, for a long time, wanted to use nerves, and which is an obvious thing I've opted for. Just in a nutshell, if you're not familiar with nerves, it's a minimal Linux which boots directly into the Beam, has a pretty minimal footprint. It's great. And it also has really great developer tooling for your workflow. You just run mix firmware to build a firmware, run once mix burn to actually burn it to a flash, to SD card, take it out of your laptop, put it in the Raspberry Pi, boot it, and you're good to go. And from there on, you can just do mix upload and do over-the-air updates. Pretty awesome. So you could just leave the whole setup sitting in the corner of the room or whatever, wherever you put it, and just do over-the-air updates. Pretty great. Next thing was picking a display. I opted for e-ink because I like e-ink, I like the feeling and the looks of it. And in particular, I wanted to pick something where I didn't immediately find an Elixir library for it because I wanted to like vibe code it myself, which is a strange term, vibe code it myself, but you know what I mean. And I found this one from Waveshare, a Chinese company, has pretty decent Python drivers. They are open. I could just look that up. They looked reasonable, so I just opted for this display. And set up Cloud Code, instructed it what I like, what I don't like, how it should, vibe code the driver for Elixir essentially, and gave it this kind of code. Like this is just a small example. The display initialization routine when you connect all the pins of the display to a Raspberry Pi and run like setting up what the pins actually do. Then you run this routine and it does some display flickering, setting up the right commands so the display is in a state where you actually can display an image. Perfect. One thing to highlight here, the code had a lot of implicit state handling. This, for instance, checks whether the hardware initialization works, and if it does not work, it just returns and does nothing. So the Claude vibe coding had to deal with all this implicit state and transfer it to proper GenServers, which was interesting. But it produced reasonable code, which in the end looked like this. Couple of switch statements, railway-oriented programming. I like the style, so it looked great. On paper, it looked great, and so during the run, which is something I wanted to highlight, which is interesting, I wanted to go full circle. Like let's set up an MCP which lets Claude fetch the documentation, write the code, iterate on it, and when it's finally done, then run mix firmware, mix upload, upload the firmware to the Raspberry Pi, and then SSH via an SSH MCP to the Raspberry Pi. To nerves and directly run commands to just check if everything is up. So going full circle, I just could run it for like minutes, hours, whatever, to actually produce something. Everything looked great, except when it wasn't. And I turned on the display, checked, started, booted up everything on the Raspberry Pi, and nothing appeared on the screen. Nothing. Like not a flicker, not everything. And the problem was that there was a tiny flip in hex codes in the migrated code, which I missed during my review because I didn't review all the lines, but most of them. And which was bad. It took me quite a long debugging, like a couple of hours debugging, putting the Elixir code on the left, Python code on the right, and going line by line. It was hurting. But in the end, the really unspectacular, like you get this display, it does some flickering, which is part of the initialization routine, and then in the end, I draw just a big black rectangle to see if all the pixels are working and clear it again in the end, which is great because I knew then everything was working. Yeah, learning here, also a little bit in what Josh also taught you in the beginning in the keynote. Probably don't let the AI code the core business logic for you, and this was the core business logic. Yeah. Well, okay, but our plan was not to show a black rectangle. My goal was to actually show the mood faces on display. And the initial thought I had, it would be nice to just take the image, the raw image of the drawn robot face, put it through some conversion pipeline, and convert it directly to display data, and show it on screen. and directly on device. I chose the image library, which has a dependency, which is VIX, which are bindings. So this was great until it didn't work for me. It didn't work for me because I need to cross-compile from macOS to ARM. Yeah, to Linux ARM. And fortunately for me, nerf support was added to the image library, to the VIX library, sorry, just in time. I tried that and got a different kind of errors. And I ran into this rabbit hole for a little while, tweaking GCC flags until I actually gave up. Oh, interesting. And split the pipeline. Split pipeline in half, one part doing on my laptop, one part doing on device. The on-device part is just taking some intermediate format, which I can easily debug, and then ran it to pixel data. And the intermediate format was as easy as you can get. I chose this PWMP1 format, where it's just a matrix of zeros and ones. Zeros are black, ones are white. Pretty great for debugging, because I can just run it on my device and see what actually is going to render on screen without actually touching the screen. Great. And then I took this, run it through pipeline, just chunking every 8 bits, so to speak, into a byte, properly aligned, render them to a display, and perfect. And the end result of this. So yay, I was really happy. And I sent this to my son, he was also happy. But of course, less happy than me because I had to do the debugging. Great. But we are lacking the interaction part right now. And the interaction part is perfectly fits to perfectly just continuing what Felix has shown in this room before about membrane. I will tell you in a second. But first, I didn't want to repeat the error I did during the migration of the Python display driver to Elixir. I didn't want to just put all the specs on Claude and just let it run and do some audio stuff, and then it didn't work. I did the opposite, instructed Claude to do the baby steps and teach me like what are the necessary things I need to do, what's the minimal setup. And lucky for me, nerfs for Raspberry Pi comes with audio also support. So it ships a lot of tools I already need. So I opted for the most simple solution. And the most simple solution is using Elixir and aPlay. Elixir to see if I have attached speakers, set volume, and aPlay to actually play demo audio. So it was confirmed, it works, everything's fine, and the rest was just like implementation detail. Now to the AI part here. I refined my plan a little bit to like what I actually wanted to have. Like I wanted to have the microphone. I speak into the microphone. I get the live transcription of what I've said or what my kid said, and then you have two parallel tracks. Essentially, the one track is the one below. You do a response generation via text generation language models, and in the end, you do some text-to-speech. So to actually you actually generate a response. And the other one is I want to also display a mood phase which corresponds to what was actually said. And for this, I needed to do some sentiment analysis using some Roberta models. Great. So where to start? I wanted to start at text-to-speech because I had no clue how to do this on device. For the other ones, I had some feeling and maybe some experimentation. Quick research showed I wanted to use Bumblebee for hosting the models on the device. And for Bumblebee, there's an open issue. Text-to-speech is currently not supported. Correct me if I'm wrong. But I just took that as a given and opted for as a Azure speech then, which is fine. Yeah, okay, this is not on device. But what about the other things? The other models, these do work because I tried it in the past, not on for nerfs, but on my device as well, just on my laptop. And initially, I wanted some like Gamma, DeepSeek, Qwen, or whatever models. The problem is there's also currently no support for some of them in Bumblebee. There is some of them are working on that, which is pretty great, thanks. But it's not there yet. So the question is, which model did I choose then? And I wanted to choose a different model, which is still capable. Like on the there are some really great comparisons on the web, and I just put in some additional blog post, which compared a couple of models, how well they perform on the Raspberry Pi. Y-axis is quality of response generation, x-axis is speed. So top right would be best, there's no top right. So just pick reasonable models. And I opted for the yellow circled one, the small M2 and the Llama 3.2 with decent sizes. And in this, I also had to switch to the Raspberry Pi 5 from a 3 that I had because it has more memory, but it works. And for sentiment analysis, I took some model which is capable of generating German emotions. Great for us. I tried to put everything on device, and I hit the cross-compilation problem again, and this time even deeper rabbit hole, until I found the suggestion of one of the great minds trying to bring hardware acceleration of the Halo head to Raspberry Pi, to nerves. They just said, yeah, use a build VM. Okay, I just use a build VM. Then that's easier. So this road bump out of the way, I then had to put in the speech to text generation. Yes, and I used the Whisper model for that. And this is where membrane come in, which is pretty awesome. I first tried to opt for some different, like more low-level library, but figured out that membrane has a lot of neat plugins, so the core is neat and the plugins are neat. And yeah, just writing down the pipeline, recording audio, and putting it to Whisper was so super simple. And apart from the right side, I just wanted to highlight one thing here because I think it's so cute. This is why I love Elixir 4, like converting these 16-bit integers to just 32-bit floats. It's so darn simple, just one line, or 2 lines if we wrap them. I like that. This is why I opted for Elixir. And yeah, in the end, the only thing that is missing was how to start a pipeline, because I didn't want the microphone run all the time and recording all the things. It's power consuming and also it's a little bit scary. So my son and I just put up a little circuit with a tiny button on there. You press it one time, then you speak, and then the second time, when you press it, then actually processing begins and you get some audio out. And yeah, everything was then set up. So let's see if I can play this to you. Cool.
Hallo MoodBot, du bist gerade live auf der Konferenz codebeam Europe 2025. Bitte stell dich doch kurz vor.
Hallo zusammen, ich bin MoodBot, ein digitaler Freund mit ganz viel Herz. Ich mag es, über Gefühle zu reden und kleine Ideen zu spinnen. Lass uns gemeinsam eine gute Zeit haben.
So of course I skipped some parts in between the video because the generation takes some time, but you get the idea. It doesn't move right now, but it can interact with you. You can press a button, speak, and there's some instructions to actually do something. So the pipeline works, which was really relieving that it actually works because I had no idea in the beginning. So yeah, quick wrap up. Lots of good things I found during this journey, like membrane. I just heard about it before, never used it before. I think it's great. Bumblebee is nice. Nerves is a pleasure to work with, is definitely, and all the Elixir goodies you get. There were a little bit of rough parts, like some libraries not yet are completely compatible with the cross-compilation to different architectures, which is a road bump, at least you need to know of. The model selection is a little bit limited, and as I said, I didn't find text-to-speech models yet. And of course, AI vibe coding, be careful, be careful. And with that, thanks a lot.
Questions?
Oh, yes.
So I wanted to know what the robot said, because I don't speak German.
Yeah, sorry for that. Yeah, so I asked the robot if it might introduce itself, because he's currently live at the codebeam conference, and he said, "Hi, I'm MoodBot. I'm a friendly robot, and I like to talk about emotions and some additional sentence I forgot about. Yeah.
Okay, maybe one more. I don't want to keep everyone from lunch. Yes.
Talked about the full circle MCP. Did that work well? So did the full circle MCP end up working well? Did you stick with that?
It worked well until I had to switch to the build VM because then the timeouts are way higher. So building on my machine took like 1 or 2 minutes at most, and on the build VM it took like 15 to 20 minutes because of emulation. But before that, the full circle is actually great. It's actually thought about like also putting up completely fancy setup, a webcam which actually looks on the screen and then takes the image and do some diffing and like really full circle. So I really will try to push in this direction because it's cool. If it's usable in the end and really worth the effort, I don't know, but it's cool.